Hello, we are starting our chapter 8.1 today. It's about sequences. So let's define sequences first. A sequence is simple way we can say it's a function whose domain is natural numbers, or in the layman terms we can say sequence is just arrangement of numbers in a specific order. Numbers, or we can say terms, in a specific order. Now, you know how the sequence of events, the literal word when we use in the language, we say something happened first and something happened next, and then the third event happened. So a sequence would be in mathematics, say A1, A2, A3, and so on. So this would be an arrangement of numbers or terms. This would be called the first term. This would be called the second term, third term, fourth term, and so on. So the order is important in a sequence. There is usually a pattern. Say I say 2, 4, 6, 8, and so on. That is a sequence. Each number is double of a natural number, double of 1, double of 2, double of 3, double of 4, and when we say so on, it means it's keep on going. And when we say so on and just leave it, that means it's a infinite sequence. Infinite means it can keep on going infinitely. On the other hand, if I say 2, 4, 6, 8, 10, this is a finite sequence. It closed. It only has 5 terms. So this would be an example of a finite sequence. Now, sequence is in general written as an. So an would mean nth. N can be any natural number. N is any natural number. So we say an is nth term of sequence. Okay. Now, in general, we would write sequence in curly braces and the general term in the middle of it. So let's look at a few examples. We have an is equal to 3n square minus 4. The question is to write first 4 terms of the sequence whose the nth term is this. That means we will have to find a1. And that means n should be equal to 1. 3 times 1 square minus 4. 3 minus 4 would be negative 1. a2, 3 times 2 whole square minus 4. 3 times 4 is 12 minus 4 would be 8. a3 would be 3 times 3 square minus 4. You can notice n is 3 in this. 3 times 3 square is 9. 27 minus 4 is 23. a4 is 3 times 4 square minus 4. 3 times 16, 48 minus 4, 44. So first 4 terms of the sequence would be written as negative 1, 8, 23, and 44. Let's try one more example. Part B has Cn. The name of the sequence is Cn, where Cn is given as this. Let's find C1. When you're finding C1, n is equal to 1. 9 times negative 1 by 3. That means in the formula, you just have to put in place of n 1. So that is 9 times negative 1/3, and we can cancel it. We will get just negative 3. C2 on the other hand, n would be 2. 9 times negative 1/3 square. When you do negative square, it becomes positive. So we have 9 times 1 by 9, which would be 1. C3, 9 times negative 1/3 cube. Negative cube is negative, so 9 times negative 3 cube is 27. So this cancels at 3, so negative 1/3. C4, 9 times negative 1/3 power 4. So we have 9 times. Negative power even is always going to be positive. So that is 1. 3 raised to power 4 is 81. That would be 1 by 9. So 4 terms of the sequence are negative 3, 1, negative 1/3 and 1 by 9. Now this is a special kind of sequence. If you notice that every term is a different sign from the previous term. So these are called alternating sequence. So this would be an example of alternating sequence. So if you observe in alternating sequence, always there will be negative raised to power n. So as n keeps changing from even to odd, the sign of the terms keeps changing from positive to negative. So another example of alternating sequence would be simply say an is equal to negative 1 raised to power n. So that term in sequence would be negative 1 raised to power 1 would be negative 1, negative 1 raised to power 2 would be positive 1, and if you keep on going, the terms keep on changing the sign. So that is one example of alternating sequence. Alternating sequence means where the sign keeps on changing. Now, some of the sequences are defined recursively. What does recursively mean? Recursive definition means that some general term of the sequence is defined as some expression or function of previous terms somehow. Okay, so first few terms are defined. In this case, a1 is given to be 4 and an is given to be double of an minus 1. So what do you think of an minus 1? An minus 1 is the previous term of an plus 1, where n has to be more than 1. So how is it defined? We are saying an, any term, is double of the previous term plus 1. A1 is given to be 4. So what if we try to find A2? From the formula, it would be double of previous term of A2 would be A1 plus 1. A1 is given to us, which is 4. So we can plug it here. What do we get? 2 times 4 plus 1 is equal to 8 plus 1, 9. So now we found A2. A3, if we have to find first 5 terms. A3 is double of the previous term of A3 would be A2 plus 1. Now, what is A2? A2 is 9. We have to put it here. What do we get? Double of 9 plus 1, which is 18 plus 1, 19. A4 would be double of previous term A3 plus 1. A3 here is 19. We plug it here in A3. What do we get? Double of 19 plus 1. Double of 19 is 38 plus 1, 39. Similarly, the last one term A5 is double of A4 plus 1. Double of 39 plus 1. Double of 39 would be 78 plus 1, 79. So we have our first 5 terms. First was given and we found other terms. Now, important about recursive is, you see here an was given as double of an minus 1 plus 1. Every term depend upon the previous term. In the previous question, if you remember, let's just look at it. Let's look at one part A. That was an was given 3n square minus 4. In this kind of problem, if I have to find a100, it's easy. I can just find 3 times 100 square minus 4. It's a simple calculation. We can find it. But in the recursive, if you have to find a100, that would be double of a99 plus 1. Now it will take us, then we have to find a99. That would be double of a98 plus 1. So it will take us like 100 calculations to find a100. So that is the disadvantage of recursively defined sequences, because we cannot directly find a large number of the term. Okay. Next we have a new concept to teach. It's called a notation, factorial notation. So when we write factorial, we write n factorial. This exclamation sign is spoken as factorial in mathematics. So what is the definition? For factorial defining, we say we start by defining 0 factorial. 0 factorial is always defined as 1. That is by definition. You don't have to find it. 0 factorial is defined as 1. 1 factorial is also defined as 1. Any other natural number is defined as n factorial is equal to n times previous number times previous number and so on until we keep on reaching 1. So we need to find the product of each of these numbers. That is called n factorial. So suppose we have to find 2 factorial. That would be 2 times 1. So that is 2. If we have to find 3 factorial, it would be start from 3 times previous times 1. Stop at 1. 3 times 2 times 1 is 6. 4 factorial, 4 times 3 times 2 times 1, 12 times 2, 24. 5 factorial, 5 times 4 times 3 times 2 times 1. If you multiply all of them, you get 120 and so on. Okay. So that is the definition of factorial. I put it here until 7 factorial. 7 factorial is 500, 5040. Let's do some examples. If I have to find part A here, 8 factorial divided by 3 factorial times 5 factorial. Now, I'm going to show you two methods. One is just let's write 8 times 7 times 6 times 5 times 4. Let's just expand it. That is 8 factorial. 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. Now in this case here 3 cancels, 2 cancels, 5, 4 cancels, 3 times 2 is 6 cancels. So we are left with 8 times 7, that is 56. So the answer to the first part would be 56. Let's try B. N factorial divided by n plus 2 factorial. Now this one is a little different. N factorial would be n times n minus 1 times n minus 2 and so on till 1. N plus 2 factorial. What would be n plus 2 factorial? N plus 2. Previous number of n plus 2 is n plus 1. Previous number of n plus 1 is n times n minus 1 times so on. Keep on going 3, 2, 1. Now if you notice, all these terms are same. N can be cancelled with n, n minus 1, n minus 2, 3, 2 and 1, right? So we're going to be cancelling all those. We are going to be left with 1 in the numerator. The denominator would be n plus 2 times n plus 1. Let's try part C. Says 6 factorial by 4 factorial. Okay, think of it like that. Can I write 6 factorial as 6 times 5? Whatever the remaining is 4 times 3 times 2 times 1 is 4 factorial. So that is another method of doing it. Denominator I'm not expanding. Now these are same. They're going to just cancel. 6 times 5 is 30. Last part, we have n factorial divided by n minus 1 factorial. Think similar terms. When I open n factorial, it is n times n minus 1 times n minus 2 times so on until 1. So what if I don't expand all that and write all that to be n minus 1 factorial and I am not expanding the denominator also. So whatever the denominator is, it's same as this number. So they can divide each other, cancel. So we are left with n. So if you notice, n factorial can be written as n times n minus 1 times n minus 2 so on till 1. This whole portion is just n minus 1 factorial. So the formula is n factorial is equal to n times n minus 1 whole factorial.